Welcome to NS Meetup. Hey guys, come in, grab a seat. We're going to get started close to on time this month. Surprising, I know, but we have a great talk, and I don't want anyone to miss it. So grab a seat, please. Thanks for coming in. Plenty of beer, and I think there was some cake over there. How's everybody doing? Got their Apple Watch picked out? You know what one you're going to order? We'll see. I'm getting that $10,000 gold one, I think. Yeah. Yeah, the strap clashes with my hats. Yeah, it doesn't work. But how about the hardware? It doesn't change. You can spend $10,000. You get the same piece of hardware. Different band. Wow. All right. Well, thanks everybody for coming to NS Meetup April 2015. Quick show of hands. How many people is this their first NS Meetup? All right, let's give you a round of applause. Thanks for coming. Welcome to the club. Well, it sounds like most of you guys have been to NS Meetup, but I'll just give you a quick overview. Every first Wednesday of the month, we meet for tech talks, beers, probably snacks, and we talk about iOS topics. So if you have a topic you'd like to hear about, please come find me. My name's Steve. I'll be bouncing around. I'll be doing some announcements, be hanging around in this area. So if you have any questions, please come see me. And one more thing I got to tell you is the bathrooms. Bathrooms are just doors past the elevator. You'll see them on the right-hand side. Feel free to get up, in, out as you need. If you have any questions, again, my name's Steve. I'm going to introduce Benji Encz. Thanks.
Good evening, everyone. Can you hear me loud and clearly? I'm not used to speaking with a microphone, so try not to be too loud. Well, first of all, thanks a lot for coming out, and also thanks a lot to Steve for organizing this meetup. It's been really great. I've been here for the last half year. Every single time it was really awesome, so it's cool to speak to you folks tonight. My name is Benji. I work at Make School. We're a company here in SF. We're currently working on a 2-year college replacement program. So that means we're basically working on a program where we teach more practical skills for software engineers. So if you're interested in the company, you can come talk to me afterwards. I personally have been developing for iOS for 3.5 years now in total. And I spent 1 year of that kind of in game development for iOS, 2D game development. And I started with ReactiveCocoa half a year ago on a side project. The first time I heard about ReactiveCocoa was way before that. I went to the GitHub repository because someone told me about it. I read a bit of the documentation, but it was kind of puzzling for me, like why I would integrate it into an app. Then I started using it in a side project, and I saw a lot of benefits. So the goal of this talk today is kind of show what is the idea behind functional reactive programming and what can ReactiveCocoa provide for your apps. Can I see a short show of hands who has used ReactiveCocoa before? Okay, actually not too many. Cool. So yeah, then that means for most of you the talk is hopefully really interesting. So I have built an example app for the matter of this talk to basically show the differences between the classic toolset that we use on iOS and the functional reactive toolset. And I'm going to start off with a short demo of this app. So I've recorded a short video. The purpose of this app is when you meet people at a meetup and you get their Twitter handle, then you maybe want to take some notes about that person, why you want to talk to them in the future if you need to follow up. So all this app does is you can enter a Twitter handle, then you can hit the add button. There's a network request going on. As soon as the network request returns, we display the details of the user. That's the app that I built for the purpose of this talk. So I want to start by diving in and looking at some features and how we implement them using the classic toolset on iOS. So this is one of the first features here. We enter the username of a Twitter user, and we have different states that the UI can be in. The first state is the user has not entered any information. You can see the text field is empty and the add button is disabled. If there's no text, then we can't request a Twitter API, so we disable the button. The second state is what I call default state. We have entered the username, but the user has not selected the add button. And the third case is when the user has entered the username and hit the add button, and we do the network request, in which case we want to disable the text field and the add button. So we have kind of an interactive UI. How would you implement that in the toolset that we usually have? I showed you, here's a state diagram, basically, of how you could implement that. So we have different events that are going on that trigger these different states and kind of activate or deactivate the text fields. And typically, how you would implement this is responding to each of these events with a certain block of code. For example, if the button is tapped, we kick off the network request. And as we do that, we disable the text field and we disable the button. If the network request returns with an error, then we enable the UI again because the user wants to re-enter information in case, for example, user entered the wrong username. And that is kind of the way we structure iOS apps typically. We have callbacks, and these callbacks execute a list of code. So the summary of that is that our state propagation is handled manually by mutating variables. So on a callback, we perform a section of code. We set, for example, text field enable to true, button enable to true, and so on. That's the way how we implement it. By state propagation, I mean the translation of these high-level states that I showed you on the other slide to the states of the actual UI component. So we as a programmer know in this state, the UI should be disabled, so we implement code to deactivate all the UI components manually. That's how we typically do that. So why is that a problem? One of the problems is that the state handling code is dispersed. I showed you the example here. We have 3 different callbacks. And each of these callbacks, we have codes where we touch the UI component and manipulate them inline. That means it's really hard for a developer to see which UI components are influenced by which state. For example, if you bring a new developer into the team and you have a more complex app, and they have to decide in a certain state to enable this button, they will have to go through the code and look in all different places where that add button is touched and where the state is changed. There's no way of seeing these high-level states directly in your code. And in very few cases, you actually have a good documentation, so this can run into problems. That is what I mean by the code is hard to read. You have to look at all the callbacks, all the delegate methods, and so on to understand which states we have and how they propagate. This also means that the code is hard to maintain. Because if someone goes in and wants to change one of the states, the developer will have to manually check if it conflicts with any of the states we implemented beforehand. Okay. Another thing I want to point out, if you think I'm overdoing it with this simple example and taking it apart that much, is that we have 3 high-level states here, but we actually have 9 possible invalid states in total. So in each of these states, we have 2 UI components that can be in 2 different states, which makes 4 possible states, but only one of them is valid. So there's a lot of room for potential error. And I think a lot of us have experienced that before when we execute code in a simulator and we see, oh, when this state transition, I forgot to deactivate a button, or I forgot to reset the state of this UI component before I switch to another one. So all of the state handling is manual, and that is error prone, even in such simple cases like here where we only have 2 UI components involved. If you don't believe me yet, then I want to show you a really classic example, which I bet that every iOS user has seen before, and that is table view cells that display incorrect images. So I've seen it in at least like 10 or 15 apps, and that is a really great example of manual state management gone wrong. In this example here, that's my Git client that I use. It's actually a Mac app, but the underlying problem is the same. On the left-hand side, you can see the profile pictures. On the right-hand side, you can see the result after scrolling wildly through the list for a couple of seconds. And what happens is the state of these cells is not reset correctly. Some of these cells still have requests attached that actually belong to other cells. And as you know, in iOS and on macOS, these cells are reused. So whenever a cell is reused, we have to manually think about all the state that is attached to a cell and reset them. That puts a lot of burden in the hand of the developer. And it's a good example of manual state management that we perform in most of our iOS code. So now the question is, how does that fit into this talk? Functional reactive programming actually provides us with a tool set to avoid this manual state management. And that's what I want to show you throughout the rest of the talk. So first of all, I want to get into the theory of functional reactive programming a little bit to show you the high-level concepts. And then I will go into the demo app and show you how you can implement an app with a functional reactive architecture from scratch. So when it comes down to comparing what we're doing at the moment and what functional reactive programming allows us to do, it actually comes down to the difference between imperative code and declarative code. These are terms that I didn't use a lot until Swift came out, because that was kind of the time where functional programming became really hip in the iOS community and people were talking about it more. So I decided to actually add a slide here to discuss imperative versus declarative. A good example of how you can look at the difference is a spreadsheet example. Some of you maybe have seen it if you listen to a similar talk. So the problem I want to solve here is I have a value in the column A and I have a value in column B. And I want to explain to someone how to derive the value in column C. I know how these two values relate and how I have to combine them to derive C. The imperative way of doing this would be a list of instructions. So I could hand this list of instructions to someone and say, perform the following steps whenever A or B changes, add 50 to value of A, subtract 10 from the value of B, add the results from step 2 and 3, and then write the result from 4 into column C. This here would be an imperative way of implementing and solving this problem. Imperative means I have a list of statements, or I have a list of instructions that are executed in order. So far, so good. By the way, I didn't mention that. If you have any questions, feel free to stop me anywhere. Cool. Let's take a look at a declarative solution. In the declarative way, we actually describe the relationship between the inputs and the outputs, instead of describing the way how we get from the inputs to the outputs through a list of instructions. So in the spreadsheet example, that means C equals A plus 50 plus B minus 10. And then we have a toolset that actually implements this relationship for us. In the example of a spreadsheet, this would just be the spreadsheet program that makes sure whenever A or B changes, C will be updated according to this formula that we have entered. At this point, we have declared the relationship. And what reactive functional programming lets us do is declare relationships between inputs and outputs. And it takes the burden of us to actually describe the steps of how we get from state A to state B. But instead, we describe these relationships and let the framework propagate the changes for us. So taking it back from this abstract example to our code, what would the imperative solution for the problem that I showed you look like for updating the button based on the text field input? And the answer is it looks exactly as what I showed you so far. Our typical toolset on iOS is using purely imperative code for the most part. That means we have event listeners, or we have callbacks, or we have delegate methods, and they implement arbitrary code. So when a button is tapped, we perform a step of sequences. The same as in the spreadsheet where I said, if A changes, perform these 5 steps to actually enter the result in C. So what we're doing at the moment is primarily imperative coding. Now the really interesting part is, what does declarative code look like? Not on a spreadsheet, but in an actual program. And I put together this diagram to show you the idea behind functional reactive programming and behind declarative coding. So what you can see here is exactly the same example. We have a text field and we have a button. And both of them can be in 2 different states. Just the way the diagram is set up is a little bit different. The inputs are grouped by component. For each UI component and for each derived state, I listed different inputs that drive the state next to it. So for the button, for the text field, for example, a button tap or a network error callback would actually trigger a state chain. The way we set it up in functional reactive programming is thinking about all of these possible inputs that decide the state of a component, and then we feed them into what I call here a decide function. We'll later see the actual implementation of that, but it's kind of the abstract idea. So we have these events that drive our state changes, and then we have a function that decides, based on the latest event, what should the state of the text field be. The big advantage here is when a new developer comes into this project and wants to see which things influence the state of the text field, then you can actually look at it one line of code that defines, or multiple lines of code, but they're all located by each other, that define the relationship between the different inputs and the derived state of the text field. That makes it, in many cases, easier to read and maintain this code. And this slide actually also is, in a nutshell, what functional reactive programming is about. We have a stateless decide function, and we have different kind of event emitters of all different kind of types that feed into the stateless function, and there we derive the state on the other end. So if you wondered what functional reactive means, the reactive part is actually responding to events. So when we set up our app architecture in a functional reactive way, that means whenever some of these input signals, some of these input events change, our state-derived function is run again from the beginning, basically. So every time something changes, we derive new state. That's reacting to outside events. And the functional part is that this decide function only depends on the inputs from these events. So it doesn't have any state. That means this function is what we call referentially transparent. Output of the function only depends on the inputs. Whenever we feed an event from a signal to this stateless function, the output will always be the same. And that means, in many cases, we can avoid a lot of bugs that we introduce by manual state management, where we have to think about which state we have to reset. In this case, the state is always derived on a clean slate based on the latest inputs. We'll go into some examples later on. So the most important summary here is that a state is derived from a defined set of inputs. Very differently than in the imperative way, where we have all of the events going on and we manually update the state of the application. So I think we covered enough of the theory to actually dive into Reactive Cocoa and look at some implementation details of the framework and how we can write functional reactive code. One important thing I have to mention is that Reactive Cocoa is currently before heading to a new major release. It's Reactive Cocoa 3. Reactive Cocoa 2 is entirely designed for Objective-C and has some compatibility issues with Swift. So for this talk today, I had to stick with Objective-C. I hope you're not too disappointed. But actually, the problem for me was much bigger because I had to get all that Objective-C code on slides, which turns out to be really difficult. So Reactive Cocoa 2 is a framework that brings the principles that I just showed you in the abstract to iOS. It does it in two ways. Firstly, it provides a whole set of classes to deal with these input events. I'm going to show them to you in a second. And secondly, it also has UIKit extensions. So when you think about different sources of events, typically you'll have something like a UI text field or UI button. And Reactive Cocoa adds certain extensions to these components that allow us to bring these UIKit components into this reactive functional world. Okay, I'm going to start talking about Reactive Cocoa with the most fundamental aspect of the framework. And these are signals. Signals are basically a thing that sends values over time. That means it can basically represent any type of future value. In iOS, we have different types of future values. Some of them are responses from network requests. Some of them are results from key value observation. What signals allow us to do, unlike in the classic toolset, is to deal with future and current values in a very similar way. When you write code for your current toolset, you have to distinguish if you have a value at a given point in time, or if you have a value that comes in the future. A value that you already have, you can calculate with that, you can work with that. If you're waiting on a value, then you have to implement callbacks and delegate methods to update that value as soon as it arrives. With a signal, we can abstract this concept away for the biggest part of our code. So more practically, it means signals can represent a whole bunch of different things: callbacks, delegate methods, results of key value observation. And as I said, they send values over time. As we go into examples of where we can use signals, I think the concept will become a little bit more concrete. So we'll have to dive into some API details of Reactive Cocoa. In Reactive Cocoa, a signal is represented by the class RACSignal. And the RACSignal lifetime is shown here on this slide. Basically, every signal at some point in time will be in a state where it sends values. That means it is listening to some event that is updating. Whenever it updates, it sends a new value to its subscribers. Then there are two different states a signal can transfer into. The one is the signal receives or turns into an error, or it actually completes. I don't want to get too much into the details of different types of signals, but there are two fundamentally different ones. They're called hot and cold signals. A hot signal is something that is ready to send a new value at any given point in time. That, for example, could be a button callback listener, because we don't have any influence when the button is tapped. But whenever it is tapped, the signal of that button will send a new value. That is called a hot signal. But because we can also represent things like network requests that are only triggered when we actually ask to run the action, we also need something like cold signals. Cold signals mean they won't send any values until someone subscribes to them and is actually interested in the result. They're basically lazy evaluators. So these are the two different types of signals. And cold signals can return as errors or they can complete. And most of the time, they're in a state where they send next values. We have a question. So the question was, is it time continuous or discrete? I would say discrete, but I'm not 100% sure if I understand the context. But yes, actually, no, they're always discrete in Reactive Cocoa. So you always get one value at a time. Like there's a send next event, and then you get a new value, and it doesn't change until the next send next event. If that answers your question, more or less. Okay, so that is what a rec signal looks like. Signals by themselves aren't too interesting because all they do is send values over time. They get interesting once we have subscribers. Subscribers are any type of objects or classes or functions, basically anything that is interested in whatever that signal returns or whatever that signal sends. So to work with signals, we have to subscribe to them. There are essentially two different ways to subscribe to signals. One of them is a binding, and the other one is an explicit subscription. I'll show you the two. In most cases, we want to work with bindings. because that is the declarative way of programming, as we'll see over the next couple of slides. But I also want to show you explicit subscription as a second example. So what does a binding mean? A classic example that I show here is where we have a text field that emits new values as soon as the user enters new values with the keyboard. So in this case, it's an H, then an E, and then an L. And you can see that the signal of this text field sends these values as they change. With a binding, what we do is tie these new values to a property. So you're basically telling the framework, whenever the signal emits a new value, assign this value to the property. So if we have set up a binding in this way, where we bind the text field to the user email property, that means whenever the user enters a new letter into the text field, the email property will automatically be updated. So it's very similar to the relationship that I showed earlier on the spreadsheet. And that itself is really already a very useful tool. We'll talk more about much more complex bindings, but the easiest way is take the value that the signal emits and assign it immediately to a property. How do we actually do that in code? Here's some Objective-C code that does that. On the left-hand side of the assignment, we have what is called the rect macro, and that helps us to assign values of a signal to a property. It takes as a first argument the object that we want to assign values to, and as a second argument, the key path. So in this case, we want to assign values to the username property of self.user. On the right-hand side, we have the signal. That is the signal that actually emits the values that we bind to this property. And here's one example of a UIKit extension provided by ReactiveCocoa. You can see there's a self.username text field .rec text signal. That text signal is provided by ReactiveCocoa on top of the UI text field and automatically emits all of the values whenever the text field value changes. So this here is the simplest use case of how you can start using ReactiveCocoa right away and get some benefits out of it. Let's look at explicit subscription. So unlike using the value that we get from the signal and assigning it directly to a property, with explicit subscription, we are allowed to perform an arbitrary block of code whenever a new value is emitted. But if you listen throughout this talk, then it basically means what we're doing here is, again, using the signal just as a callback. Because if we perform arbitrary code when we get a new value from a signal, then we're basically back in imperative world. We just have a list of instructions that gets run every time an event occurs. So typically, you want to avoid subscription and use bindings instead, where the values propagate for our application automatically and get assigned to other objects automatically, instead of performing arbitrary code. In some rare cases, you won't get around using this explicit subscription. This is what it looks like. You can say self-username text field .rect text signal, and then you can call the subscribe next method that allows you to perform an arbitrary block. And as a parameter, you get the latest value that has been emitted. So just in case you see this, you typically want to try to avoid it. In the beginning, it's sometimes more difficult, but we'll see later that there's something called signal operators that often can replace explicit subscription and solve the problems that you run into when using Reactive Cocoa. So just in case you ever come back and review these slides, I put this in as a reminder: prefer binding over explicit subscription, just in order to have more declarative, less imperative code. Okay, so now I want to dive into some actual examples of Reactive Cocoa code from the example app that I built. The first thing I want to look at are model view bindings with Reactive Cocoa. So just very straightforward. We have a model, we have a view that renders that model, and we want to bind a subset of the properties and display them on screen. Here I'm showing you the detail cell that is basically filled with the user information from Twitter. And the code that I implemented to achieve this is basically shown on the slide. I didn't show all the bindings, but all of the bindings look the same, so I just showed you the two example ones. You can see all of this code is placed in awake from lib. That means, in this case, I used a storyboard file. And as soon as that file is created, I set up all the relationships between the model and the view up front. So I don't have any callbacks, delegates, etc. that later update any values. I set all of them up statically at the beginning of the runtime of the lifetime of this object. So what are we doing here? We're using the rect macro to assign the value of a signal to a property. For example, in the first line, we are assigning the value to avatar imageview.image. And the rect macro, as I said, allows us to assign values that are emitted by a signal. What is new here is the second macro, the RACObserve macro. The RACObserve macro basically uses key value observation to track changes on any arbitrary property and turns that into a signal. We have a question. Sorry? Okay. No, actually, good. You can interrupt me. This way around, not, but on the ReactiveCocoa, it actually makes a difference. I'm talking about it in a second. So the ReactiveCocoa macro takes key value observation, and whenever a new value is observed, that signal that is created with this macro emits that new value. So in this case, what we're saying, whenever model.avatar changes, we assign the new value to the image view. The interesting part here is when you ever have written such code, you maybe remember situations where you have to think about when you get a model, is the view available already? So it can be that you get the model before the view is loaded in some cases, or the other way around, the view loads, but you don't know if you have a reference to a model yet. With ReactiveCocoa, you can avoid that kind of situation. We have to check for that with the RACObserve macro. So in this case, what I'm doing on self, I'm observing the model.avatar key path, which means that both the model and the avatar are observed for changes. That means if this code runs and I don't have a model yet, that image will be blank. As soon as someone assigns a model, image will be updated. As soon as the image that belongs to that model changes, the image also will be updated. So it's one of the examples where with imperative code, you have to think about the sequence and the order of code. You have to think about which parts you already have. And with ReactiveCocoa, you can actually set up that relationship, declare it once, and have the framework implement the relationship for you. Cool. Any questions on this one? So yeah. It's not with timers. It's basically the same as key value observation. So yeah, it uses key value observation under covers. In general, ReactiveCocoa's performance is a little bit lower than if you would do something imperative, because there's a lot of framework code going on. I'll talk about that actually at the end. But in most apps, it does make a big difference. Cool. So you could stop here, actually. We have covered model view, and I've showed you a great example of how you can use ReactiveCocoa in your apps. And a lot of people only use it to this extent. It's really a great way of having nicer key value observation APIs. And it's very useful up to that slide already. But what I want to show you today is that it can also be used as an architecture for your app. So not only as a utility to bind values, but actually as a kind of a mindset of how you design your app up front. So what we have to cover is not only away from a model in the view, just rendering a model, but actually the communication. What happens when we have an interactive app where events happen in the view and trigger changes in the model, where we have network requests going on, and so on. Before I can talk about how we implemented ReactiveCocoa, I'll have to talk about two more aspects of the framework. The first one is signal operators. So in this example here, I'm using a binding, and I have a similar example as on my very first slide. We have a text field that changes, and user can enter input in there, and we have a button which gets enabled when the text field actually has some value in it, and gets disabled when the text field is empty. So the problem here, if you want to use bindings, is that the output of the signal should be a Boolean value, but the signal actually emits strings. And that is one of the first problems you run into when you just want to use bindings in a simple manner. What we usually do in ReactiveCocoa when we have different inputs and outputs and want to transform them is use signal operators. One of the most common signal operators in my example code here is the map operator. The map operator takes each value emitted by the signal, performs some operation, and returns one value again that is transformed in a certain way. So in this specific case, the map operator actually turns every string into a Boolean value. And the implementation, we'll see it later, is pretty simple. It says, if the string is empty, return no. If the string is not empty, return yes. So we can take these emitted values, put them through an operator, and transform them, and then bind them to a property. Is it a question? Yeah. Right. Did I mix it up? Oh. Thanks a lot. Okay. So I hope that the concept here is clear of signal operators. Basically allows to transform values. Not in all cases do the things we bind to have the same type of signals that emit the value. Then we need to have transformations. And that is a very simple operator. I'm going to show more complex ones later on. So the second thing we need to know before we can dive into more ReactiveCocoa code is the RecCommand class. The RecCommand is required because we have some signals that don't exist at the beginning of the runtime. So the first example I showed you, we bind with key value observation. And key value observation is something you can do as soon as the model that we want is available. But we also have things that are triggered by user interaction. For example, in this app, when the user hits the add button, we triggered a network request. And that actually creates a signal. That signal is not available at the beginning of the runtime. It's only available when the user taps the button. What the recommend does is it allows subscribers to subscribe to dynamically created signals. So for signals that aren't available at the beginning, but are kind of hooked up to some outside interaction. I don't want to get too much into the details before I show you the code, but the main idea is I can create signals through user interaction, and I can give an outside class ability to subscribe to these signals before they actually exist. Cool. So back to our original question. How can we build an app that is interactive only on ReactiveCocoa and only based on signals? It turns out that when you work this way with bindings and value transformations, that the controller in your architecture doesn't have a lot of work to do in it. Typically, the main goal of the main work the controller does is mediation of imperative code between the view and the model. So you have some callbacks, and then you handle it with imperative code. You update something in a model. You listen for more callbacks from the model. You update a view. When we build an app with ReactiveCocoa from scratch, we try to avoid all of that imperative code. And then we kind of eliminate the role or reduce the role of the controller quite a lot. So there's an architecture that goes along with ReactiveCocoa and functional reactive programming called the model view model architecture. It's not too important for this talk since I only touch on it lightly, and the differences aren't too dramatic. It's more a semantical difference. In this architecture, the view model replaces the controller, and that primarily means that it acts more as a glue between a model and a view. So in most cases, the view model will have bindings to the model, and the view will have bindings to the view model. And we don't have a lot of code outside of these bindings. Whereas the role of controller is more active in the architecture. The view model also stores all of the state of the view. So in this concept here, the view is a very, very thin layer that only renders all of the properties and bindings available in the view model. So for example, the question if an error message is shown or hidden would be stored in the view model. And the view would only listen for that property and then actually display the UI view based on that. And as we'll see later, that has some implications for testing, because we can end up actually testing our view models for most of the cases, and that means we don't have to test UI code. Very subtle difference, but the view model has a much more passive role in this architecture. I'll show it you throughout the next example slides. So let's take a closer look at the second step here, where we actually activate the add button. The first two steps actually of this three-step process, where the user enters something and we activate that add button. And I want to show you how you would create the classes involved, the models and the view models, and how you actually implement the signals for this activating and deactivating that I talked about the last couple of slides. So in this example here, I have involved two different classes. The first one is the person adding view model, and the second one is the person adding view. The person adding view, you can see on the bottom right, has the text field and the button. And the only thing it does is actually bind to the username search text, and that is a property in the view model. So the actual search text is stored in the view model, and it is bound to the text field with the bindings that we've seen before. In this specific case, we are using a two-way binding. I won't get into details of that in code, but a two-way binding means that we're updating the relationship in both directions. That means when the view model changes the search text, it is reflected in the text field. If the text field updates, it is reflected in the view model. The second important aspect here is that the view is setting the rec command on the add button. This means the view model can actually provide a callback for the code that should run when the user hits the add button. And the only role of the view is taking that rec command from the view model and adding it to the UI button. And the actual callback is implemented in that command. You'll see the code for that later. So the view in this case is really only taking things that are available through the view model and attaching them to UI components. And the last important part in this setup is the add button enabled signal that is part of the person adding view model and drives whether the add button is enabled or disabled. So just so that you believe me that the view in this case really has only very little simple code, I'll show you a part of the initialization. So hooking up the button, the rec command to the button looks like this. We have self add Twitter button.rec command equals self.viewModel add Twitter button command. And the second thing we do is enable the text field based on the signal from the view model by binding the text field enabled signal to username text field enabled. So this is basically all of what your code will look like in the view in most cases, just binding things provided by the view model. Now let's take a look at how the add button enabled signal that I've been talking about is actually implemented. And that is now part of the person adding view model. This is the code that drives enabling or disabling of the button. The first thing you can see is on the assignment side is that we have the RACObserve macro to observe self username search text, which means that is how we create our first signal. Whenever the username search text changes, the signal shall emit a new value. As I said, we need a Boolean value instead of a string value. That's why we have to perform an operator on the output of the signal to turn it into a Boolean value. So we do that by implementing the map function on the signal. Then we get the search text as a parameter. We check if the search text is empty. If it is empty, then we return no. And if it's filled, then we return yes. So in this case, we have created a signal through a base signal with ReactiveCocoa and have transformed the signal using map to actually emit Boolean values instead of string values. In action, it looks like that, the communication between the view and the view model. The view passes the string to the view model, and if the string is empty, it returns no. If the string is non-empty, it returns yes, and the add button is automatically enabled. So I've talked about enabling and disabling buttons now for a while. I want to get into the more interesting part of this app, and that is actually the networking aspect and updating the UI based on a network request. So we're now going to look at the second part of this three-step process, where the user has entered text, hit the add button, and we're waiting for the response, and upon response, update the information that is displayed. To understand it, it's important to know how I set up this app. So basically, these two views here, you can see the person adding view and the person detail view, are a child of a person container view. And the person container view will display either of these two at any point in time. If that cell actually has a person, then we are displaying the person detail view. And if we haven't added a person yet, then we're displaying the person adding view. Cool. So let's take a look at how we start that network request. And that is where the rec command comes in. So as you remember, the view model is providing this command to the view, and the view is attaching it to the button. That means whenever the button is tapped, this rec command runs. It actually has two interesting parts. Let's first focus on the first two lines. So we're creating a rec command, and that allows us to also provide a signal in the initializer. That signal tells ReactiveCocoa whether this command is enabled or disabled. So basically, the API provides us with a feature that allows us to enable or disable commands. And if the command is attached to UI component, then UI component will become enabled or disabled through the command that is attached to it. So in this case, this command is attached to the button. So if we disable the command, the button gets disabled. And as I said, this is driven by the self-add button enabled signal. So that is what we're setting up in this lineup here. Is that more or less clear still? Yeah? Cool. Then the more interesting part is this block that runs. And this runs every time that the user hits the add button. The responsibility of this block is to return a signal. That means here we can kick off the network request and return the signal that we get from that network request to the API. So all we're doing in this case is calling to an outside class called Twitter client, and we request the info for username from self.username search text. And we'll see later how the network request is implemented. But the really cool part here is all we have to do is exactly one thing. We're only kicking off the network request. That is the only responsibility of the button. In this code here, we don't have to do any callback handling. We don't have to deal with the result of the request. Typically, in most cases, you would have the code that handles the response right here in the adding view model. But in the architecture here, the container is actually interested in the response of this network request. And the person adding view model really only should trigger that network request and ignore the response values and leave them for someone else to consume them. So yeah, question? No, I just realized that as I was talking. But actually, yes, I am in this case, sorry. So the input in this case for a recommend is actually the UI component that triggered the request. It's not the actual value of the, so I have to use it here, yeah, sorry. At the end, yeah, when I showed network code. Cool, so now mentioned, as soon as we get a response from this network request, we want to switch from that input view to the detail view that displays the information about the user. And that is something that has to happen in that container view that sits on top of these two different child views. And here's all the code that basically runs and performs that change between these two different subviews. Let's first focus on the top part. And that here, I promise, is the most complicated Rack code that I'm going to talk about. So bear with me if it's a little bit too complicated for now. But basically what we're doing here is from the container view model, we're listening for network requests that are kicked off by the person adding view, which is the child view of the container. We're doing that by first observing self-person adding view model. That means in this case here, we don't always have the adding view attached to the container, only in certain cases. We say whenever we have it attached, perform the next piece of code. Then we use an operator, an operator that we haven't talked about yet, the flatten map operator. The flatten map operator allows us to append a signal, chain a signal to another signal, and only return the values from the latest signal in that chain to the actual subscriber. So you can basically just build a chain of operations. So here we're saying whenever the person adding view model changes, subscribe to the add Twitter button command dot execution signals. That is basically the signals that are dynamically created by hitting the button. And then we perform the concat operator, which means subscribe to the inner signal of the signal that is dynamically created. Now, if you haven't used ReactiveCocoa before today, then you will definitely not understand it. But what it is doing is the add button creates a signal dynamically, and we in the parent view can grab in there and say whenever that signal becomes available, subscribe to it. So we can set up a static relationship for something that will exist in the future. So once we have a handle on that signal, things become a lot easier. I want to derive the UI state from the signal. And to derive the UI state, I need to create a different signal based on this Twitter fetch signal. Basically, what I want to say is the default is that we show the view that has the button and the text field. And whenever we have a network request that responds with an actual person value, then we want to switch into the detail. So I'm taking this Twitter fetch signal, and then I'm using the map operator to change the value, because in this case, the Twitter fetch signal actually returns a Twitter account. So profile information, avatar, and so on. But that is not the input that we need to decide which UI we want to display. The input for which UI we want to display is actually two different enum values that I chose here. One is adding view state, and the other one is the detailed view state. What I'm saying here is whenever the Twitter fetch signal returns a value, then this signal should return the adding view state value. But initially, we want to start with the detailed view state. And actually, I've mixed it up in this case again. So I switched the two values around. It should be exactly the other way around. Sorry about that. But we're basically building a signal. And we're basing it on the Twitter fetch signal, but using an operator called start with to inject a first initial value into the signal. So start with basically says, as soon as someone subscribes to this, send this first value. After that, send all the values that this other signal emits. It's another example of how we can use a signal operator to build a compound signal instead of using imperative code. Alternatively, I could have set the value of the UI state initially and only use the signal to update it. But in this case, I built the signal with an operator where I can set an initial value as part of the signal, and all subsequent values are delivered by a second signal. So this just shows like what you can do with signal operators. That is kind of the hardest part to learn when you get into ReactiveCocoa. But once you start writing ReactiveCocoa code, you will see that almost everything you want to do, there is an operator to build that compound signal that represents the state that you want to derive. So once I have that state signal that now will always return one of the two UI states, I bind that to self.ui state. The code that I don't show here is that one that removes the subview and adds the subview as soon as the UI state changes. The second thing I'm doing is binding the result from that Twitter request to self.person. So person is actually the model that is stored here. And whenever the Twitter request returns a new person, I want to update it in the container view model. And I'm doing that with this binding. So in this specific case, I can use the same signal for two different things by, in one case, assigning it directly with a binding to a variable. In another case, using a signal operator to modify the signal in a way that I needed to bind it to a different variable. Hope this example shows at least the power of ReactiveCocoa. So what we have accomplished now is the transition from entering a username, hitting the add button, and then getting to the detail. One thing I want to show you, because that's the way I got into Reactive Cocoa in the first place, is how you can build a sequence of network requests and a sequence of operation with signals. So the actual Twitter API request that I called earlier was in the info for username method. This info for username method returns a rec signal. The code here is really not that relevant, but the essential underlying idea is we're performing a sequence of different operations and chaining them using the flatten map operator. There's basically a four-step process involved here. Firstly, log in the user with the credentials. Once we have the logged in user, we can use the client to actually get the user information. When we have the user information, we can perform a download of the image that belongs to the user. That's the second step. And once we have the image and the user info, we can build a person object based on all of the information returned from the API. Now, probably when you look at this code, you will say, oh, that doesn't look better at all than using callbacks. But if you think about all the nested callbacks you would need to implement this in one kind of one place, you would end up with really, really horrible code. And it has happened to me before a lot that I had a lot of nested requests. And the problem is when you use callbacks, you usually have to handle the error and the success case in one place. In Reactive Cocoa, we're chaining all of these signals, and we're only kind of modeling the happy path. So all of these trainings will only go on if every of these signals actually returns a value and doesn't error out. If an error occurs, then that is propagated up to the subscriber. And the subscriber can handle the errors from all of these combined signals in one single place. So whoever subscribes to the signal, if any of these signals here that are combined throw an error, there will only be one error block that has to be implemented. And if this request is successful, then the subscriber actually gets a person up after the login and all of these steps have been performed as part of this method. So the flatten map operator was basically the first thing how I used Reactive Cocoa just for my networking layer. So I hope I showed you how you can actually use Reactive Cocoa to build entire applications. I've just built a subset, but I showed some examples of Reactive Cocoa code that is more than just binding and updating buttons, but actually using network requests and driving your application state. So the very last thing I want to show you is how you can test code with Reactive Cocoa, because I think the architecture that we just showed, the model view model architecture, also has some positive effects on testing. The one example test that I built here is testing the UI. And once again, we're testing that add button that kicks off the Twitter network request. I don't know who has done testing before on iOS. Oh, a bunch of people. Cool. It's getting more and more. That's nice. So basically what I'm testing here is when the add button is tapped, I want to make sure that the Twitter client actually gets that request to fetch the information from the Twitter API. So the first part that I do is I set up a mock object. A mock object basically means I'm taking this object. I don't really need a real implementation. I only need to verify that a method on this object is called. Then I set up the person adding view model. That's one line of code, and I hand that Twitter mock into there. Then I set the search text on this view model, and then I can call the add Twitter button command. So because the view model provides the implementation of the button callback, I can trigger it with a line of code instead of actually working with UIKit at all in this place. So I can execute a button callback without that I have to have a UI button. And that's kind of the power of what a view model can do. By implementing everything without UIKit and have UIKit only as a binding layer, my testing code becomes simpler. Another thing about testing with Reactive Cocoa is when you have set your entire app up with the architecture that I showed you, with only based on signals, then you have a very good testing plan. If you test all of your signals, you have covered basically the majority of your application. And testing signals is pretty easy because all you have to do is provide the required input for the signal and checking for the output. Typically, when you test iOS apps, in many cases, you'll have to set up the state of a component in the environment it belongs to. Then you'll have to send some messages to that component. Then you'll have to check if it changed the environment in the way that you expect. When testing signals, you typically only provide input, then you subscribe to the signal and test that the signal returns the correct output. And then the testing becomes very much like testing pure functional code, because you provide input, test output. Mostly pretty simple. So I'm going to come to the summary. After I spoke a lot about implementation details, I want to get back to the original idea, because I basically want to capture two things. On the one the concepts, but on the other, also the implementation. If you haven't used Reactive Cocoa before, then the implementation details are not that relevant for today. That's why I want to close with the concepts. The goal of using Reactive Cocoa and functional reactive programming is getting into a state like this, where we have well-defined inputs that produce well-defined outputs for our state and our application, and where most of our application state is actually derived instead of us manually manipulating it, because it produces less error-prone code, and also in many cases, code that is better readable. Remember the example, if I want to see all components that modify a certain UI component, all possible inputs, all possible events, with Reactive Cocoa, I can see them in the one signal that drives the state change. So my summary is that I admit that Rack introduces a vastly different programming model, and it can also be harder to debug. So I actually want to start with a negative point, because I see why a lot of people think that Reactive Cocoa is not a good idea. And it's definitely true if you look at Reactive Cocoa code, if you're not familiar with the framework, it's very difficult to understand the code. So if you work on a team where people are not happy to adapt this technology, it's definitely not a good idea to just start writing Reactive Cocoa code tomorrow. It's really something you have to agree to. Yeah, question? Cool. Yeah, nice. Awesome. So he mentioned on Coursera there's a course on reactive programming, so that's pretty cool. Nice. So on the positive side, though, once you have kind of tried out that paradigm and you agree that it's a good way to write application, then Reactive Cocoa provides tools for writing declarative code. And when you think about a spreadsheet example, the declarative example, we have C equals A plus B, and we have kind of a formula where the semantics of what we're doing are really clear. Then I would say we can agree that when we can do it, declarative code is typically better than imperative code. Just looking at the list of statements of how to transform values in a table is much more complicated than looking at the actual relationship, the one-line relationship between C, A, and B. And derived state, as I hoped I could show, solves a couple of issues where developers have to think about which state a component can be in and manually reset the state. Also, shortly touched model view model as a kind of architecture that can eliminate controller complexity. So once you start using bindings a lot, you don't really need controllers that have imperative code that kind of bridge between the view and the model, handle callbacks and all that stuff. It doesn't becomes almost unnecessary. And the model view model architecture makes it easier to write testable code. I hope I could show an example, but in most cases, you can actually test the view model without the view. And that makes testing UI code, in many cases, a lot easier. Finally, I want to close with a last quote by a very famous computer scientist called Dijkstra. And first of all, I want to thank a lot of blog posts and other talks that quoted him in the context of reactive programming. What he said is, our intellectual powers are rather geared to master static relations, and our powers to visualize processes evolving in time are relatively poor developed. Now, he was a little bit too old to talk about Reactive Cocoa. Actually, this year was part of a paper where he was talking about the downsides of using goto as a statement in other programming languages. But funny enough, what he says here applies very much to reactive functional programming as well. When we embrace reactive functional programming, the goal is that we have these static relationships set up at the beginning of the runtime that define how we handle future values up front. Instead of having code that basically we have to remember in which order it executes, which callbacks are called after which, we have to think about if the model is available before the view, if all of our parameters are available when we perform a line of code. That is kind of the underlying goal. So, thank you very much for your attention. So I've got the code up here on GitHub. If you want to take a look at it, we'll send the slides around. I also linked to 2 resources. One of them is a really great book that is available on EPUB. That's how I get started with Reactive Cocoa. The other one is a blog post that is more arguing for the ideas behind functional reactive programming. And I also want to thank Ashfur, Morgan Chan, Gerald Monaco, Florian Kruger, and Dave Lee for input and feedback on the talk.
All right, let's just open up the Q&A. And if you're interested in asking a question, I'll give you the mic. And go ahead. And also, if you're following NSMeetup on Twitter, we just tweeted the slides, so you don't have to take a picture of that.
I know you said that debugging Reactive Cocoa is a lot trickier. I've experienced the same thing myself. Do you have any tips or tricks? Like, it seems just like a black hole when you try and debug React.
Yeah, so first of all, maybe for the people that haven't used Reactive Cocoa before, the reason why the debugging is harder is your call stack doesn't really show anymore which call actually resulted in this the current line being run. Because you have these signals that respond to events, it's much harder to track back the source that actually triggered the event. The way I have dealt with that developing this app is thinking much more upfront about the signal design. So instead of like just going ahead and coding, I spend more time thinking about the relevant inputs, and then spending a lot of time designing the signals and testing these signals in isolation. And then once I see that a signal behaves in a way that I want to, then hook it up. That was kind of the approach that I took to decompose the problem a little bit. That's helpful. Yeah. Back over here.
For the model view model binding, did you try to use just key value observing to see how easy that would have been without adding the dependency on Reactive Cocoa?
Yes, so generally, if you would only do bindings, you can definitely do it just with KVO. I personally think the API for using KVO in Objective-C is a little bit ugly, so I wouldn't even mind having the dependency just for that. But yeah, as I showed, I think Reactive Cocoa can use much broader scope, so that's why I would bring it in as a design for the actual application, for the application logic as well. And there, it can provide a lot more than just key value observe.
I was just wondering, as far as like introducing Reactive Cocoa to a project, when does a controller or something reach a level of complexity that you say, this is the way to do it? Definitely want to use Reactive Cocoa.
So common examples that I see a lot in code bases are controllers that are a UI table view delegate, a UI table view data source, and also handle callbacks from 2 or 3 different network requests. And that is very common, happens when you have a complex view that has a lot of interaction with a backend. Then you end up having all of that code in your controller that communicates with all of the different subviews. So we have just handling multiple network requests and multiple delegates. And I think that is where it gets complicated enough. But if you want to try it out in a project, I think one of the best places to start is actually just the networking layer. So one of my apps I worked on, I started translating to Reactive Cocoa. And I started just replacing the network layer, removing all callbacks, and turning them into signals. And that was like the easiest way to get started, and it gives you immediate benefit even if you stick with model view controller and keep the rest of the architecture the same. And once you get used to using signals in the context of networking, then you'll see other benefits of directly binding the results from these signals and so on. So I think that's a good way to kind of start. For the recording.
So my question is about just transforming values on the background thread or something that takes a bit of time to do. How would you go about doing that? Sprinkle GCD in the blocks, or what's the best way?
Yeah. So the question was about how do you handle things you want to run in the background, for example, value transformations. And the cool part about Reactive Cocoa is that there's an operator on a signal that allows you to do exactly that. It's called the deliver on operator, and it allows you to deliver any signal on a specific thread. So you can say, I want the result of this signal to be delivered on a background thread. Then I perform a bunch of transformations. And then the final signal I want to be delivered on the UI thread again before I actually bind it to UI component. So there's a good way of doing that.
All right, real quick announcements. We tweeted out the slides. They're going to be up on NS Meetup tonight, probably tomorrow, something like that. Also, if you're interested in hearing about a topic, please come tell me. Also, if you're interested in giving a talk like Benji did today, please come see me. A lot of our speakers come up, present me with an idea, we put it up there, and they go give a talk just like this. So you guys can do it. Please come give back to the community, give a talk. We'd really appreciate it. So if you got an idea, come see me. And then finally, there's beer, there's some snacks over there. You're welcome to take it. We're here till 9 o'clock, and just make sure you clean up after yourself so I don't have to. All right, we'll see you guys next month. Thanks.